Hello, I'm Mark Ross with New Core Incorporated. For over 25 years, we have been in the same business as our name, manufacturing new cores for stators, rotors, armatures, and pole pieces. Over the years, we've seen virtually every kind of core pass through our plant, and we have experimented with about any way imaginable to rebuild these cores effectively and efficiently. In the early days, we would unstack, sand, recoat, and restack laminations. Over time, we found that nothing could service a core like being replaced. That has been our focus and our work. But today, I'm here to introduce you to a product that can restore an electric motor core that has higher than acceptable core losses without replacing the core and without restacking it. I'm referring to ZMI Core Shield. ZMI is an aqueous solution of phosphoric acid with proprietary materials in suspension. ZMI is not simply a recoating of shorted laminations. Instead, by following tightly scripted application methods, ZMI is able to both etch and re-insulate shorted laminations, resulting in a durable core plate. Unlike restacking, the application of ZMI is not labor intensive. However, each step is critical for a favorable outcome. The purpose of this video is not only to introduce you to ZMI Core Shield, but also to provide a demonstration of the application process. Let's get started. For our demonstration today, we will be treating a small 5.5 kW stator, which weighs about 43 pounds. Tests with ZMI have been done on stators in excess of 38,000 pounds and rated at 9.5 megawatts. The tests were just as successful as with smaller stators, dropping the core losses to acceptable levels. However, for demonstration purposes, our video will feature this small sample stator. Before we begin the treatment, we need to do a core loss test on the stator. This will give us a base value from which to improve. As it is, this stator shows losses of 7.75 watts per pound. This figure is higher than we want and makes the stator a viable candidate for treatment with ZMI Core Shield. We will be preparing the stator for treatment by scuffing the bore with a drum sander. The sander used should have 40 to 100 grit drums. The goal is to open up the laminations for the solution to penetrate as far as possible into the core and to assure a clean metal surface for the ZMI solution to interact with. We do not want to smear or smooth the laminations, but to scuff them. For efficiency's sake, we're using a small industrial oven to preheat the stator. Our target is a temperature between 180 to 200 degrees Fahrenheit. The stator is heated to facilitate the solution saturating the core. As we all know, heat draws, which is what we want to happen. We want the heat to draw the solution deep into the core. While the core comes up to temperature, we can also begin to heat up our tank filled with ZMI Core Shield. There are a variety of ways to heat ZMI. A simple stove or hot plate will work for small quantities. The solution should not be heated in an oven, as evaporation will occur. Again, we are looking for a target temperature of between 180 and 200 degrees Fahrenheit. ZMI is a weak solution of phosphoric acid. Still, care should be exercised when using the product. Good ventilation is important, and the user should employ appropriate protection methods. The printed instructions offer more details. For our demonstration, we will be immersing the stator in ZMI. The small sample stator facilitates that. All tanks used for dipping with ZMI should be stainless steel. However, ZMI is formulated so that the solution is just as effective when it is sprayed on the core. Tests have shown no appreciable differences between immersing and wetting a core. When a core is treated by the wetting or spraying method, there are a few additional considerations. First, the most damaged part of the core should be down to maximize saturation. A plastic or stainless steel pan should be placed below the core to catch runoff for either respraying or to rebottle for future use. We will be submerging this stator in ZMI for between 15 and 20 minutes. The time is the same if the wetting method is used. Our next step is to rinse the core off with cold water. The purpose of the rinse cycle is to remove any residue of zinc salts. Next, the core is placed back into the oven for the drying cycle. Our final step is to retest the stator with the core loss tester. This stator now shows significant improvement with losses of 3.854 watts per pound. This concludes our introduction and demonstration of ZMI Core Shield. As you can tell, ZMI Core Shield holds great potential for an electrical apparatus repair center. The product does have its limits. ZMI cannot replace missing steel from damaged cores. Where bearing failure or electrical shorting has physically destroyed the core plate, the only solution is replacement of the core. However, where the core loss values are high or where there are significant hot spots in the core, ZMI can provide an effective and efficient solution. Tests have shown that this solution improves the core loss results even on newly manufactured cores. In addition, cores with windings in place can be treated without any adverse effect on the winding or the insulation. With no known shelf life, ZMI Core Shield is an important tool to stock for the apparatus repair facility that is concerned with good core loss tests. ZMI Core Shield is now available for purchase through Nucor Incorporated. On our website, there is documentation, including a technical paper released to the IEEE by senior member Chuck Young. The paper goes into great detail regarding ZMI Core Shield, the process for application, and numerous case studies. Another document is a printed copy of the instructions. The website for both of these documents is www.nucorincorporated.com. Again, this is Mark Ross with Nucor. Thanks for watching.